Question number 85. Let capital letter M and small letter m respectively the maximum and the minimum value of the function f of x, that is tan inverse of sin x plus cos x in 0 to pi by 2. Then we have to find the value of tan m minus m. Let's see the solution of this question. So here f of x is given, f of x which is equal to tan inverse of sin x plus cos x. So for finding maximum or minimum value, we have to differentiate the function both the side with respect to x. So ddx of f of x which is equal to ddx of tan inverse sin x plus cos x. So we know that ddx of tan inverse x which is equal to 1 divided by 1 plus x square. So here ddx of tan inverse of sin x plus cos x. So in the place of x we have a sin x plus cos x. So here we use chain rule. So which we able to write as 1 divided by 1 plus, in the place of x there is a sin x plus cos x whole square ddx of sin x plus cos x, which we will get by applying the chain rule. So in left hand side ddx of f of x we are able to write f dash x. So this implies that f dash x we are able to write as 1 upon 1 plus sin x plus cos x whole square ddx of sin x, that is cos x, ddx of cos x, that is minus sin x. So for finding the value of x, that is the critical point, we have to take f dash x which is equal to 0. So this implies that we will get cos x minus sin x divided by 1 plus sin x plus cos x whole square equal to 0. If we solve this, then this we multiply with right hand side, then we will get cos x minus sin x which is equal to 0. So this implies that we will get cos x minus sin x which is equal to 0. So this we are able to write as cos x which is equal to sin x. This implies that 1 which is equal to sin x by cos x. So sin x by cos x we are able to write tan x which is equal to 1. So in the place of 1 we are able to write tan pi by 4, tan pi by 4. When we equate this with that, then we will get x which is equal to pi by 4. So x equal to pi by 4 is our critical point. Now we are going to check the first derivative test. We are taking the value x less than pi by 4. Another value we will take x greater than pi by 4. Now we are going to find f dash x. If the f dash x from left hand side to right hand side, we will get positive to negative. Then we call the value is maximum value. If value is negative to positive, then we call minimum value. So this is our f dash x. So here this part is always positive. So our f dash x is positive or negative, it decide only with the help of this part. So this we find out with the help of cos graph and sine graph. So here this is the cos graph and this is the sine graph, and x equal to pi by 4, this is our critical point. So when we take x less than pi by 4, then we will see f dash x is positive or negative. When the value of x is less than pi by 4, now we will see the graph cos x graph, which is lies above the sin x graph. So the value of the cos x is greater than the value of the sin x. So this will give the positive value. So when x less than pi by 4, we will get f dash x, which is positive. So after that we are going to check when x greater than pi by 4, f dash x is positive or negative. When the value of x is greater than pi by 4, then we will see the graph, the sin x graph is lies above the cos x graph. Then the value of the sin x is greater than the value of the cos x. That means this part of f dash x give negative value. So f dash x, which will give negative. Now from here, by first derivative test, we will get f dash x travel positive to negative. So at x equal to pi by 4, the function attain the maximum value. So at x equal to pi by 4, we will get the maximum value. So maximum value we will take as a m, which is equal to tan inverse of sine. In the place of x, we will write pi by 4 plus cos. In the place of x, we will write pi by 4. So which is equal to tan inverse sine pi by 4 means 1 by root 2 plus cos pi by 4 means 1 by root 2, which is equal to tan inverse of 2 root 2. We rationalize root 2 divided by root 2. Then we will get tan inverse 2 root 2 by 2. So 2 and 2 cancel, we will get tan inverse root 2. So our maximum value m, we will get tan inverse of root 2. For minimum value, we will take x equal to 0 or x equal to pi by 2. So when x equal to 0, then m, that is the minimum value, we write tan inverse sine of 0 plus cos of 0, which is equal to tan inverse sine of 0 means 0 plus cos of 0 means 1, which is equal to tan inverse of 1. Now when we take x equal to pi by 2, then the minimum value m, we will get tan inverse of sine pi by 2 plus cos pi by 2, which we will get tan inverse of sine pi by 2, that is 1, plus cos pi by 2, that is 0, which is equal to tan inverse 1. So both the value, that is the x equal to 0 and x equal to pi by 2, both attain minimum value, that is tan inverse 1. So our maximum value m, which is equal to tan inverse root 2, and the minimum value m, which is equal to tan inverse of 1. Now our maximum value m, which is tan inverse root 2, and the minimum value small m, which is equal to tan inverse 1. So therefore tan of maximum m minus minimum m, which is equal to tan of tan inverse root 2 minus tan inverse 1. So we know that tan inverse x minus tan inverse y, which is equal to tan inverse of x minus y divided by 1 plus xy. So we break this with the help of this formula. We take root 2 as a x and 1 as a y. So this we are able to write as tan, that is tan inverse root 2 minus 1 divided by 1 plus root 2 into 1. Tan is cancelled with tan inverse x, so which is equal to root 2 minus 1 divided by root 2 plus 1. Now we rationalize, then root 2 minus 1 divided by root 2 minus 1, which is equal to root 2 minus 1 whole square divided by root 2 whole square minus 1 whole square. Now we break this with the help of a minus b whole square. So this is equal to root 2 whole square minus 2 into root 2 into 1 plus 1 whole square divided by root 2 whole square, that is 2, 1 square is 1. So this is equal to root 2 whole square, that is 2 minus 2 root 2 plus 1, and 2 minus 1, that is 1. Now 2 plus 1, that is 3. So this is equal to 3 minus 2 root 2. So this is our answer. Option number A is our correct option.